Welcome, listeners. Today we're diving into an electrifying topic that's quite literally out of this world: nuclear fusion. Yep, we're talking about the future of energy, and it all revolves around two fascinating designs: Tokamaks and Stellarators. Think of it as the epic showdown between two heavyweights in the fusion arena. So let's kick things off by understanding why fusion is even on our radar, especially with the current energy crisis we're facing, right?
Right. So fusion is like the energy source of the stars, isn't it? But how does it actually work? I mean, the idea of smashing atoms together sounds, well, a bit sci-fi.
Absolutely. Fusion is the process that powers stars like our sun. When they fuse together hydrogen nuclei, they create helium and release an immense amount of energy. Now, the trick here is to replicate those conditions on Earth. We're talking about temperatures and pressures that can strip electrons from atoms, producing a hot plasma where the magic happens. It's truly like trying to bottle a star.
Whoa, that's insane. So, are we trying to create a miniature sun on Earth? How do you even keep that plasma in check without it just exploding everywhere?
Great question. That's where magnetic confinement comes in. We use powerful magnetic fields to control that plasma, preventing it from touching the walls of the reactor, which would cool it down and halt the fusion reaction. Now, Tokamaks and Stellarators are the two leading designs for this. Tokamak means toroidal chamber with magnetic coils, and it's shaped like a donut. You can visualize it as a giant ring donut, where the plasma is held in by a helical magnetic field generated by both external coils and an induced current in the plasma itself.
Oh, wow. So it's like trying to keep a slippery eel in a donut? But I've heard Stellarators operate differently. What's up with that?
Right again. The Stellarator, think of it as a more complex donut, if you will. It generates its magnetic field purely through external coils, without that central solenoid. This means less risk of inducing instabilities, and it allows for a steady-state operation. Imagine it like a perfectly balanced bicycle that can keep going without you pedaling. The Wendelstein 7X project is a stellar example of this, aiming for plasma discharges lasting up to 30 minutes. Quite a leap, if you ask me.
Interesting. But if Stellarators are so steady, wouldn't that make them simpler? Why did Tokamaks take the lead in the beginning?
Good catch. Initially, Tokamaks showed superior plasma confinement, and in the 1960s they were all the rage. Think of it as the cool kid in fusion research. However, as time went on, Stellarators have evolved significantly. They're challenging the Tokamak's dominance by showing promising stability and efficiency. It's been a bit like a marathon. Tokamak sprinted ahead at first, but Stellarators are pacing themselves for a strong finish.
Oh, and can we talk about the plasma stability? Why is that so crucial? I mean, if the fusion reaction goes haywire...
Right, plasma stability is paramount because instabilities can lead to disruptions. Tokamaks are, unfortunately, a bit susceptible to these, while Stellarators tend to remain more stable, thanks to their design. Picture trying to keep a campfire lit on a windy day. If the wind blows too strongly, it flickers out. In contrast, the Stellarator is like a well-sheltered fire that can sustain itself regardless of the gusts.
That's a great analogy. So, what do you think the future holds for both technologies? Are we going to see a fusion of concepts like a hybrid Tokamak-Stellarator?
Fantastic idea. There's definitely potential for hybrid solutions. The advancements in materials, especially with high-temperature superconductors, are propelling fusion research forward for both designs. The competition fosters innovation, which might just lead us to the clean energy utopia we dream of. It's like how nature thrives through diversity. In fusion, ideas can cross-pollinate, leading to breakthroughs we can't even envision yet.
That's mind-blowing. It's like each design is pushing the other to be better. You know, I've seen movies where we're just one breakthrough away from saving the planet. Is fusion really that feasible?
Yes, the path to sustainable fusion energy might be challenging, but projects like Wendelstein 7X are paving the way. The research can unlock new realms of energy generation that could solve our energy dilemmas.
Wow, I just hope I get to see this in my lifetime. I mean, imagine the possibilities. Who knew fusion reactors could be so exciting?
Right, it's a thrilling frontier, and I truly believe we're just on the cusp of a revolution in how we produce and consume energy.